Hello everyone, this is my first YouTube video, so it's definitely going to suck, but that's okay because it's supposed to be this way. In this video I'm going to take a naive approach at building a brushless motor and a brushless motor controller, starting from first principles, a purely empirical approach. Let's dive in.
And starting from first principles, of course, means placing a wire in a magnetic field and passing a current through it. Now the wire hangs from some ball bearings to reduce friction, and we can clearly see a deflection away from the magnet. But if we turn the magnet around, leaving the direction of the current as it is, and pass the current again, and now we see a traction. A moving wire is a good start, but hardly a motor. We need a longer wire to obtain a greater force, but we also want to keep our motor small. To achieve that, we wind a coil. Now a current passing through such a coil will cause the magnet placed on a scrap rotor to attract the coil or repel it.
Now, coils and magnets are arguably the most important functional part of a motor, but we still have a lot of options left, like the number of coils, the number of magnets, and whether the magnets should rotate inside or outside the coils. There are other parameters such as speed, width, available space, and torque. I've picked one that's also easy to make.
I've put 3 coils pointing outward at a 120-degree angle. The coils are connected at the center. This is called the star configuration, and the whole assembly a stator. Since they're connected at the center, there are only 3 terminals exposed to the outside world. Now the other part with the magnets is called a rotor. It connects to the stator with a ball bearing, and I've made 2 versions, one with 4 and one with 8 magnets. I would say that the more magnets the better, as you get more torque. It makes no sense passing current through a coil if there's no magnet around.
So here it gets a little more interesting. We have 3 coils and a bunch of magnets that can rotate around them. And we have 3 terminals exposed to the outside through which we can pass current. Let me show you on a piece of paper. We have our 3 coils connected together in a star configuration with the centered point in common, and the 3 terminals exposed to the outside world. And let's call the coils A, B, and C, because why not? And if we apply a voltage difference to a pair of coils, let's say A and B, we get a current through A and B. And if we have a magnet placed around somewhere appropriately, the coils will exert a force on the magnet and turn it. And now if we cleverly swap the direction of the current within our 6 options, we can make the magnets turn around and round and round. So we just have to find a clever way of commutating the direction of the current to make the motor turn around. And that's it. Now let's see how to do it.
Well, we can quite simply commutate all the 6 possible current configurations with just a single power supply and an array of 6 switches. We place the motor terminals between those switches, and we activate switches in pairs. Say we want to send current from A to B coils, we turn on the switches A1 and B2, connecting the terminal A to 12 volts and the terminal B to 0 volts. And if we want to reverse that current, we turn on terminal switch B1 and switch A2. And we can do the same for the other pairs.
Now we set aside the motor for a moment and turn towards the controller, because the switches shown in the schematics are of course cannot be manual switches, but they get replaced with MOSFETs. that in this case act exactly as switches, but the switching is done through applying a voltage to the gate pin. And each gate pin is connected to a pin of the microcontroller. So when we turn the voltage on the microcontroller pin to on, it energizes the gate and the MOSFET begins to conduct. And it's the same as was shown with the switch on the schematic. Plus, there is in this case, there is a LED connected to the gate, so we will be able to see which gates are energized. Now, an open question still remains. What's the correct MOSFET switching order that would make the magnetic field turn 60 degrees with each step? Let me show you an example. Starting off with the A1 V2 configuration, we press forward, watch the rotor. When we move into the A1 C2 configuration, it moves. We step forward into B1 and C2, then B1 A2, C1 A2, C1 V2, and we're back, and observe that the rotor has moved half a circle. So if we go another 6 steps, 3, 4, 5, 6, we've made a full circle. So now this motor may not be much, but it has a really interesting feature, and that is it has an interchangeable rotor. We can simply take off this one, and see it has 4 magnets, and switch it with another one that has double the magnets, 8 magnets. So when we install this one, we now see that the step is half the step of the previous one. So if I place a little dot, it will take 24 steps to make a full revolution. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Half. 1, 2, 3, 4, 5, 6. 3/4. 1, 2, 3, 4, 5, 6.
Now let's take a look at the Arduino program that will actually spin the motor. We first have the 6 pins defined that correspond to the MOSFETs, to the gates of the MOSFETs. We then have an initial pause between commutations. We have the pins of course set to output. This is an additional pin just used for the manual commutation. And each commutation we clear all the pins, which is not very efficient, but it works. This is another function used just for the manual commutation with the button. And then we have a delay function between the commutations, and it uses some different ranges for different values based on what the function delay and delay microseconds can accept. And here is the meat of the program, the actual commutations set in the same sequence that were set manually, just done automatically by the Arduino. A thing to note is also a variable pause between commutations that will make our motor spin faster, faster and faster.
Now finally, drum roll, we'll load the program and hopefully see the motor spinning. And that's it. This was a demonstration of a brushless motor and a brushless motor controller functioning in open loop. To make it really useful, I would have to add some feedback with sensors so the controller would know where the rotor is to maximize torque. But other than that, I hope you've enjoyed it and see you next time.